All right, welcome back. So we are the next set of problems for us to do. We're going to do number 9, okay, A and B. So evaluate the following integrals: sine to the fourth x, cosine to the fourth x, and we'll get this guy down here. Okay, so these are, again, pretty standard ideas here. So let's go ahead and take a look. All right, so why did they do that to me? Okay. Oh, I know why. Okay, so here we go. So what did we say? We said this was the integral. These are indefinite, so there's always a plus c. So we have a sine to the fourth x and a cosine to the fourth x dx, right? So one thing we have to remember, right, is that sine of 2 theta was equal to 2 sine theta cosine theta. So I'm going to go ahead and say that sine theta cosine theta is equal to 1/2 sine 2 theta. Just in preparation for what's going to happen next here is I'm going to remember that cosine 2 theta is equal to 2 cosine squared theta minus 1, okay? Or 1 minus 2 sine squared theta, or cosine squared theta minus sine squared theta, okay? What we're going to do here is we're going to say that, so cosine equals all of these. So we could say that 2 sine squared theta is equal to 1 minus cosine 2 theta, right? So move this over here, move that over there, okay? So sine squared theta was equal to 1, well, I'll write it this way because that's how I'm going to use it. Okay, so it's 1/2, right, 1/2, 1 minus cosine 2 theta. Okay, we're also going to note that cosine squared theta, all right, and this is where these formulas come from, okay, is going to be 1/2, and that's going to be 1 plus, right, because we're going to add the 1 to both sides, 1 plus cosine of 2 theta. Okay, so we're going to need these a little bit later on. So we're going to need all 3 of the ones I put down. Okay, so here, what I'm going to note is that these are both to the 4th power, huh? So this is going to be sine x times cosine x raised to the 4th power dx. Okay, and I am going to note that there's probably other ways of doing this, right? Taking your sine squared and turning it into a cosine, taking your sine squared and turning it back into another cosine. I mean, there are other ways of doing this. Okay, but this is the way I saw it, so that's how we're going to go. So here we have sine theta cosine theta is equal to 1/2 sine 2 theta raised to the 4th power dx. Okay, now since theta here, right, so far theta is equal to x, so that's going to be 2x. Okay, that's going to change a little bit later on as well. All right, now we still can't integrate this, right? I don't have a du, so what we're going to do is we're going to say, oh, well, 2 to the 4th, that's 1/16 integral, and then we've got sine of 2x, sine squared of 2x squared, right? That's sine to the 4th dx. So we're going to look at this and we're going to say, hey, wait a minute. Sine squared of theta is equal to, right, in this case, right, theta is equal to 2x, okay, because that's my theta here is 2x. So we're going to say that is equal to 16th integral, right? And now this is still going to be squared, but this is going to be 1/2 parentheses 1 minus cosine of 2 theta, right? Move that over a little bit, squared. Okay, so that whole thing has got to be squared. D theta by the, or d, sorry, dx. All right, dx. Pause this a moment to deal with a kitty that probably needs to be put away somewhere. All right, that hopefully will help. She has a heart condition. We can't get out. Can't get her spayed. We can't get her neutered because she can't tolerate the anesthesia. So we just have a kitty that goes in the heat about every few weeks. Unfortunately, she goes in the heat about every 3 weeks, and the heat lasts about 4 weeks. So yeah, there we are. She's adorable though. I'll put her on sometime. Camera shy though. All right, square this, right? So we have, this is a 4. So 16 times 4, I think that's 1 over 64 here. So we're just going to move that out. Integral, and now we have, oops, this is not squared. This is not, because the sine squared was this. So we still have 1 squared left. We have 1 minus cosine 2 theta squared dx. We got to go deal with this. All right. Again, can't do a u just yet. So this is 1 over 64 integral, and we're going to square this out. 1 minus 2 cosine 2 theta. In this case, theta was 2x, so 2 theta is equal to 4x. Does that make sense? All right, so here we go. That's 4x. All right, and then plus, and then this is cosine squared 4x. Okay, so we squared it. Beautiful. We got a cosine squared. Okay, we can't have a cosine squared. We have to do something about that. Dx, by the way. So this is 1 over 64. And now we have integral 1 minus 2 cosine 4x. That'll be okay. We can integrate that. Okay, so 1 minus 2 cosine 4x. And then this, we're going to have to say, well, that's cosine squared is really 1/2 1 plus cosine of 2 theta. Theta is now what? Is 4x. So 2 theta is going to be 8x. So 1 plus cosine 2 theta, 8x. Okay. Let's deal with this a little bit. Okay, I promise that was the last trig one we have to do. Okay, but 1 over 64 integral, and here we have 1 minus cosine 4x plus 1/2 plus 1/2 cosine 8x dx. I'm going to combine these and say, well, 1 plus 1/2 is 1.5. Okay, so we have 3 halves, right? Minus 2 cosine 4x plus 1/2 cosine 8x dx. And now we have a perfectly reasonable integral to deal with. Okay, just a little bit of algebra. Okay. So, you know, if the derivative of sine is cosine, that would make sense that the integral of cosine would be sine, right? Cosine theta is equal to sine theta, put d theta here, plus c. Okay. So here we have it. It's 1 over 64. Integrate 3 halves. Okay. 3 halves x minus 2. And then we have sine of 4x times 1/4. Okay, now I want you just to ponder this one right here. If I take the derivative, right, of sine 4x times 1/4, my derivative here is going to be cosine 4x times its chain, so that's times 4. And I'm going to read right back to where I started with, because the 1/4 and the 4 are going to cancel. So I didn't do a u substitution here. I more of guessed and checked it, but you know, it's important to do the checking part. Okay, don't just guess. And then plus 1/2. And the same thing's going to happen here. I'm going to have sine of 8x times 1/8. And again, if I take the derivative of sine, I get cosine x times cosine 8x times its chain, which is times 8. If I cancel all of this, I'll have back what I started with. Okay. Let's see. All right. So I think we can pretty much go ahead and do something here. So this is going to be 3 over what, 128 minus what's 64 times 4. right? So that's on my bottom, but actually I'm going to cancel a 2 here, so this is going to be minus half of 256 is going to be, I think it's 128 again, times 2. Oh, divided by 2. 128. So 128 sine 4x, okay, and then plus, and then we've got 16, right? 16 times 64. 16 times 64, and what do we end up with? 1024. Okay, so we have 1 over 1024 sine 8x plus c. Right? And there's our answer for that problem there. Okay. That problem up here. Like I said, there's probably slightly easier ways to go. Not that easy, because if we had a sign, like if we had an odd power of one of these, this problem would have been so much easier. Okay, so realize not all of them have to be this terrible, but because I didn't have an odd power here on either one, we had to do it the long way. And here it is. Well, again, there's probably some other things you could do. Right? There's not just one way to solve this, but that's the way I saw it. Okay, next one. Okay, so we have integral of a polynomial 3x squared plus 2x plus 1 times the natural log of 4x dx. Okay. So this is kind of like a classic polynomial times a logarithm. You should be thinking, I'll bet this is integration by parts. Okay, so what we're going to do is we're going to set up a u. That's going to be ln 4x. Derivative is going to be 1 over x. Okay, just as an aside. Okay, ln of 4x is equal to ln 4 plus ln x. And if I take this derivative, natural log 4 is a constant, so we're just taking the derivative of natural log x. So there you go. Okay, and my derivative, right, dv is equal to 3x squared plus 2x plus 1. Integrate this, so we end up with, what, x cubed over 3. So that cancels. X squared over 2, so that can't, wow, it's almost like somebody got this out of a textbook or something. Amazing. All right, so integration by parts, right? It's uv minus the integral v du. Okay, so here's my uv, and that is x cubed plus x squared plus x times natural log of 4x minus integral. And then what we're going to have here, right, is x cubed plus x squared plus x divided by x. And this little piece here, right? So we have x squared plus x ln 4 minus integral. Go ahead and do some of this magic here, and we're going to have x squared plus x plus 1. Nice integral, right? So if you know what you're doing on, not every problem I pick has to be the hardest problem that you've ever seen before. I know some of them have been. Some of them have been. Okay. ln 4x here, 4x minus, go ahead and integrate this. So this is 1/3 x cubed plus 1/2 x squared plus x plus c. And there you go. That's delightful. That is how you do those two problems. Okay, definitely expect one like this. Definitely expect an integration by parts. I promise you. Can't get out of Calc 2 without doing integration by parts. All right, so thank you for that, and I will move on to the next one, hopefully with less noise.